Here we go. Welcome to the SUSE QE Tools Workshop at the beginning of July 2022. Last week, we have skipped this workshop due to the SUSE Hack Week, but now we can share lessons learned from an incident which we recently had. We called it openqa SUSE DE is not reachable anymore with response time greater than 30 seconds, and that was on the 20th of June. There's a ticket link, so you can follow the complete story within there. So how did it look like? We had this ticket created by Nick at the very early European morning on Monday after a weekend, that openqa SUSE DE is not reachable anymore, or sometimes it is reachable, but it's having very long response times. And we had multiple alerts over the weekend, so we did receive automatic alerts and reacted on that. And these reports had been confirmed by users who are saying that we see problems or we cannot reach SUSE DE. So how did it look like from the alert perspective? So for example, what we can see here is we can see that there's, let me disable my camera overlay. So what we can see here is the HTTP response times that we monitor for openqa SUSE DE. And it's starting here on the 18th of June. What we see is that normally we have response times in the range of well below 500 milliseconds with some spikes and some longer requests. It can take a bit longer, but well below the alerting threshold of 4 seconds. Anton?
Sorry, maybe I'm too fast, but in this picture, I don't see anything higher than 4 seconds. And...
Very good point. So we did observe some problems and we did receive some alerts. I come to that, but not from this graph, which would be obvious maybe. So, you know, what we see is that we have good response times, and then here certainly the graph looks different, like only very spotty that we have data at all. But if we do have data, it doesn't look too bad. And then one day later, that's on Sunday in the morning, it starts to be still very spotty and become worse with response time being higher, but still below that alerting threshold. We have other graphs. For example, we had the
sorry, Oli. Get back to the previous graph.
HTTP response.
Do you have a clear understanding why you don't have any data here? Why it's not? Maybe in this blind spots you actually get, like, I don't know, these 30-second things, but somehow it's not recorded, or what?
Yeah, so I will come to that. I don't want to explain everything from the start. So to walk with you, like and enjoy the story and make you understand, like, why couldn't we, you know, immediately react on something, but we needed to investigate. So yeah, what the actual alerts that we received were only to some minion jobs failing. You know, we have this background jobs which do some less critical work, like compressing screenshots or preparing the results for the details or executing job post hooks. And some of them were failing. And we realized that they were failing because they couldn't get a response within time. So what these alerts were telling us is the same. What we see here is that, well, the system looks available, but doesn't provide a response within a reasonable time sometimes. And then what we found is also what looked suspicious is we have this graph. And this graph is the database rows that we that we try to retrieve within the openqa internal database. And certainly it's looking suspicious that during the time when everything was working perfectly normal, you see a line which is like a near flat zero. It's actually not zero, but it's in a range of some tens of thousands of rows that are returned every second. And then suddenly we see that sudden increase and we go in the range of millions. So an increase of like a factor of thousands. So Yanis, you're asking, that was after the database update, right? Yes, you're spot on. So what happened at that time? Well, I can tell you that it all started, let's go back in time a bit. It all started in April, because in April, we had a problem that suddenly all jobs on openqa SUSE QE that are finishing are ending as incomplete. And they were ending with incomplete, and the error message was something like openqa schema results, database, yada yada, error integer out of range. So what happened? Well, in a database table, you have indices, and the index that we use in that case for so-called job modules was running out of int max, like what we have for integer max. What we did at this time to say like, right, especially on openqa SUSE QE for certain reasons, we are having a lot of modules. So actually it's reasonable to, well, we investigated different ideas, like could we just cycle around and reuse job module IDs or optimize somewhere else, and we just decided like, well, actually use big int. So, you know, instead of 4-byte for integer index, we use 8-byte for integer index, and this will give us a sufficiently high range of it. So we identified that, and that was done like near immediate within 1 day. But afterwards, of course, we also say like, what does that mean for the future? So we came up with a follow-up task, which is to say, let's review all our database tables to make sure that we use big int where it makes sense, because this was only job modules. We did it for job modules, but then we decided that we also want to look at all our database tables and decide where do we need to go to big int instead. The next candidate would be screenshots or jobs itself. So in that case, what we did is we prepared separate pull requests, and the pull requests, I can also show you the one pull request here, which is avoid running out of database IDs. So this was the one database migration where we altered all the different tables to use ID, and we decided like, well, okay, that's like a big hammer. Let's do it step by step. So it's closed, it wasn't merged. And instead what we did is, okay, sorry, it's not, yeah, it's linked here. So we decided that we will do this change, which is only the jobs table. And we carefully check in before how long will the migration take, what will be the performance impact. And we decided, same as every good team does, we decided like, well, we will select a time when there would be less impact on users. So we said on Friday afternoon or Saturday morning, we will deploy this change. And we did that. So what happened? We already foresaw a potential significant performance impact during migration and rollout, especially in openqa SUSE QE. So we planned the migration to starting on Friday afternoon. I conducted a migration on Saturday morning, first on openqa OpenSUSE.org, and after I saw no significant impact, I also triggered the migration on OSD about 4 hours later. That was at 10 o'clock Zulu time. That's 12 o'clock European time on Saturday, 18th of June. And the services on OSD were generally reachable 18 minutes again afterwards. So this is like 18 minutes that the actual migration took. So, you know, there was actually a downtime, but hardly anybody noticed. And only then afterwards, we could see, when I considered the initial step finished, I considered the migration itself done, then we observed that there was a performance impact, which we did expect, but we wouldn't know how exactly it would look like. So, but here we could see what it looked like, because suddenly the rows in database were, after the initial migration, let's go back here. You see this small dip? This was the actual migration. And during this time, the time was so low because the web UI was responsive, but it couldn't return any data. It was blocking all requests because the actual migration was going on. And then afterwards, it was going back up. So this looked like normal operation, but then there were only very spotty responses. And what we see here is that, well, queries are having like 1,000 times more rows returned. So we figured that's bad. This will have the impact that we saw. And we also saw the impact in other parameters like CPU usage being maxed out and memory being higher and all these things. Then what did we do? We took a look on openqa OpenSUSE.org, where we have where we use Munin, but for monitoring, but effectively it's showing the same kind of data. It's the number of rows in Postgres database queries conducted over time. And we see that in the early morning of 18th of June, we see a corresponding increase in the rows. And this lasts for nearly 2 days. But nobody ever complained about performance problems on openqa OpenSUSE.org. And we didn't observe any performance problems on openqa OpenSUSE.org. And then suddenly it went down to still higher than previous, but a good level. And then sometime later, after 2020 of June, it returned back to what I would say is the normal level. So what happened? I mean, I can tell you, we didn't do any active manual action going from here to here. So who wants to make a guess? Who doesn't know it already? What happened? Why the sudden increase? Why no problem visible by users? And why did it fix itself? Anyone wants to make a guess?
The queues.
Hannes?
I'm not sure. Maybe something canceled the queues.
No, I would say normal operation was going on. Anna?
Can it be that it was not observed because it was weekend? I don't know. I just checked that 18 and 19 of June was weekend.
Yes, right. I mean, this was our intention, right? It was our intention to do it on the weekend so that less people would be impacted. But let's put it like this. If jobs would be failing or running into incompletes or timeouts, same as what happened on openqa SUSE QE, then users of openqa OpenSUSE.org would also realize on Monday. So, you know, on Monday, maybe they would access the web UI and the web UI itself would be responsive. But they would see the jobs from Saturday and Sunday, and they would see that there's a much higher fail or incomplete ratio, and there wasn't. So after change schema indices from int to big int, yes. So that was the change from int to big int. And then we had like 1,000 times more rows returned in queries. So anybody else wants to make a guess, like why that increase? Who knows about how databases behave?
So there was some, I don't know, cache rebuild or indexes rebuild, something like this.
Yeah, you're onto something, right? There's actually not a cache, but so what Postgres is doing is it has a query planner. I hope I'm getting the words right here so people can correct me when you're more an expert in databases. So we use queries a lot, right? Like select something from something and then combine it with other tables to insert job results, to show job results, to render the page test overview and all that. So that's a potentially critical operation and it needs to be efficient. And what Postgres does is it can plan these queries and it can optimize the path that the queries take. And it does that also automatically. So you can rely on Postgres using an optimized path. Felix?
Was there somewhere a mix-up between big int and int in one of the joins that made Progress then copy the whole database or convert it?
Very good. So likely that was part of the problem, that we joined tables together where not all indices were of the same type. But that mix-up didn't, like last forever because it still fixed itself, right?
Yeah, right.
So yes, we identified that as a potentially problematic area, and we fixed that also with time. I mean, we had planned to fix that anyway by going step by step and converting more and more tables over time and migrating them. And actually, we are still not done yet. So there are more tables that we also want to migrate. So another migration we will trigger likely today, this Friday afternoon. Let's see what happens then. But what happened is that Postgres couldn't rely on all the knowledge and all the experience regarding using optimized queries. And this is why it was still being able to conduct the queries, but in a much less optimal fashion, like think 1,000 times worse. But after that time, then likely there was enough data collected so that Postgres could optimize the queries again by itself automatically. And that was then again providing this huge step downwards where it kind of fixed itself. You can see that they're still above average and then it went down further. This was then likely done by manual actions. So what we did is we explicitly vacuumed individual database tables, and we also, after the vacuum, manually triggered the query analyzer to reanalyze and create new query plans. Yeah?
Sorry, can you elaborate what does it mean, vacuum a table? Because
a vacuum a table. So think of a table which has many rows, and then you add more rows, and then sometimes you delete rows in between, which we do with openqa jobs, right? So you will have some holes in the middle. A vacuum is like defragmenting, where you would say delete all the holes and reorder the database on the persistent storage so that you have actually, yes, storage space used and less of a sparse table, but rather have all the data together. And that can also have positive impact on performance. additionally, it can trigger the query analyzer to reanalyze what's the best path to take, because that makes a difference. Janis?
A simple restart of openqa wouldn't help.
Sorry, I didn't get that. Say again?
Will a simple restart of the server help?
Good question. So let's go back to here. To roll out the changes, obviously we did restart the service, and then over this time we didn't trigger any restart. What happened around this time is, this is Sunday morning. This is when we automatically apply the underlying OS packages upgrade within the openqa SUSE infrastructure. And at this time, definitely all the services were restarted. And restarting the services, and even systems are rebooted when there is a kernel update or a base system update. What we did see is that there was an impact by that, but it wasn't a positive one. So I can say simply restarting the services doesn't fix the problem. So yeah, so much about this query from 03. And after we saw that in 03, and when we could see that it could fix itself, that there were multiple paths we could take. There was the hypothesis that it could be that, well, maybe OSD just needs to run in that degraded situation for some days until it can fix itself. And if we do try to touch the system and do something about it, then maybe that learning process would always start from scratch and we wouldn't gain anything, but we would rather prolong the problematic time. And the other idea was, which we then eventually tried, to select, well, actually, let's try to speed up by being a bit more aggressive and saying that additionally to the migration and the query plan optimization, which likely would have fixed itself if we would have just waited. Okay, so we could have done that, but we wanted to speed it up. So we did trigger individual vacuum and query analyzers. And the effect we can see then here. So this is the same graph in before, it's just a bit later period. So we can see that bad time, and then in the morning of the 20th of June, this is 2 days after the migration has been conducted. First, we tried some mitigations. So we stopped a lot of non-critical, at this time we didn't exactly understand it properly. We stopped a lot of non-critical services. And actually, as you can see here, this is rows being higher than what we wanted to have, which is like a near flat zero line. But this made the system responsive. So over the course of Monday, if you would have used the system, probably wouldn't have seen any impact, because I would say at the early European morning until late European afternoon, there was no problem at all visible to the outside, except for a slightly increased load. And then suddenly, and really, we don't know why, suddenly in the afternoon, like at 5 p.m. or something, it became worse again. And the original problem was never fixed up to that. We tried multiple other things. For example, this period is when we actually disabled monitoring, because also our monitoring is querying a lot from the database to get statistics. And we already knew it has something to do with the database, and we didn't know who would trigger the queries, which would end up causing this big load. So we wanted to reduce the load in the database. It helped a little bit to disable that monitoring, so we wouldn't even see that number of rows, but didn't really fix it enough so that there would be no visible impact. So there was still a significant impact. And then you can see here that's the next day. That was on Tuesday, the 21st of June. We still had a problem. And then with the multiple things that we then applied, we could over time remedy and fix it. So we did vacuum of individual tables. Then we merged that one pull request, which would also update one adjacent index to also use BigInt directly, so that the types would align. And starting from lunchtime on Tuesday, I would say it was fully workable and usable. It's just that still we could see that performance impact by these spikes in rows. And only here we came back to the normal level. And these spikes are fine. I mean, sometimes, like if you try to query all the jobs, I mean, yeah, this is what you will get. But only the next day we could really say, like, yeah, okay, we did everything we could, and we are back to the new normal level. Any questions or notes about this graph here?
I'm sorry, maybe I'm again too fast, but I still didn't get what was the actual problem with the Postgres. Why we get this performance degradation, and of course what was actual fix, because
yes, okay, so I will go into more detail. So we discussed what happened and what we did. So now let's dive in further. We did conduct a 5 why session. So we collected the what happened, and then we said, like, why didn't we see any bad impact directly after migration? Well, the migration itself finished, and I could see that the system generally works, especially on O3, but the query planner could not have been finished at the time. So the query planner could not know at this time, like, what are efficient routes to take. So the web UI itself, like as a service, it was up and reachable. Likely we would have seen problems looking at the HTTP responses when trying multiple times. And also there were minion job alerts, but these were like very vague indications of a problem at this time. Just to tell you that we tried to really think about improvements on every level. So every of these whys should have some ideas, like what can we do to improve. So we have one open ticket, which is about trying to improve the alerts, so that we did see alerts, but they were not really helpful. And I think if we would have an alert which is more spot on, more saying like, hey, the HTTP response is still okay-ish, but there are outages, or maybe there's a significant performance increase if you can do that, decrease, then yeah, then we could react even quicker in the future. So another thing, it was weekend and the load was low because nobody was scheduling or restarting jobs. That was helping us. So it was a good idea to deploy explicitly during a time of low load. I have no question about that. And we did expect some performance regressions directly after the migration. But what we learned is that it's a good idea to plan a manual vacuum analyze for each table affected by the migration. And this is confirmed by PostgreSQL developers. They said, like, yes, after migrating the types in tables, it makes sense to explicitly trigger a vacuum analyze process, which is vacuum the table, analyzing it, and it will make PostgreSQL generate a new query plan. So that's just best practice that we were not aware about in before, and we learned about that. So we already have a pull request to improve that, added to our documentation, our contribution documentation. Like, if you're changing the schema, then please consider doing that. And the idea is also to conduct an automatic vacuum analyze after migration. So this was the first why. Why did OSD have performance issues a few hours after the big migration? Initially, after the start of services, everything was available, but the query planner could not optimize the plan, so significant problems can only show up over time. So we also learned about the PG stat extension in PostgreSQL, which can provide a lot of interesting details, like which one are the most we were already monitoring for slow queries in before to identify problems, but the question is also about the cumulative effect. Maybe there are some queries which are still quick, but 100 times slower, and they would show up in the graph if you accumulate them. So a good idea is to run a pgstat statements reset, keep an eye on the slowest queries after doing significant changes to the database, in particular the schema. So we also have that included in the documentation because, it's something that we can do manually to select, okay, I did a migration. Now let's reset statistics. Let's Postgres collect new statistics on what are the slowest queries now, because the situation can change after such migration. We already have post-deployment checks in OSD deployment in various time periods after migration. For example, we have, I can also show you that. So we have the OSD deployment, which is a GitLab CI pipeline. And you can see these various stages, and there was an automatic deployment also today in the morning. So we are checking the deployment environment. We are checking also, is openqa openSUSE.org as our canary deployment. The first deployment always happens on openqa openSUSE.org. If that one is up and is fine, only then we can continue. Are there any alerts? Only if that is fine, then we do pre-deploy, including a backup, then we deploy, and then we monitor post-deploy. So we check, are there any alerts popping up 1 minute after deployment, 10 minutes after deployment, 1 hour after deployment, 8 hours after deployment. And on set day, the 1 minute after deployment was saying everything is fine. And I think the 10-minute deployment, 10 minutes after deployment was also saying everything is fine. And only then later an alert happened. So we already have that, and we confirmed that this is a good idea because it did signal us that there are problems. So why did we not fix it sooner? Well, we observed some problems over the weekend and would have expected that they might even resolve themselves. The first order vacuum should have triggered analyze, including the query planner. And this is backed by our observation on 03, which was never showing significant problems, and it did improve itself after 2 days. Also, we did not want to make it worse because the services were generally available. So, the question was, can we, do we just let the system run and try to improve itself? Or would we risk making it even worse by touching the system and then it's not available at all anymore? We identified that it is a good idea to look at the monitoring data and not only alerts after such exceptional deployments or changes. So, alerts are kind of Boolean, either there is an alert or not. But there is this quantitative analysis of data that we could have monitored a bit more closely after such change. And of course, we needed the time to check our database changes for consistency. And we did learn new tooling while we were looking into the incidents. We learned about pgstat and explain analyze and vacuum analyze, which honestly I didn't know in before about. So yeah, and understanding our rows dashboard was really helpful. So it is a good idea to learn more about Postgres. Well, consider doing courses. I've also created a ticket about that. And we want to extend the openqa documentation with best practices, what to do after migration. Now, question 4 is, why was OSD looking completely fine after Monday morning when we only applied some mitigations like stopping services, and it only became bad again in the late afternoon? Well, our suspicion is that maybe people were using OSD less and less with our mitigations because there were, you guys probably were expecting that there are problems, so maybe you were relying less on openqa over the course of the day anyway. And yes, we did stop the openqa scheduler. So that was seemingly helping to lessen the load. OSD was working on jobs, including the openqa scheduler for parts of the time. But then around 1,000 new jobs in that afternoon, which I would say normally is nothing special, but that seems to have triggered a cascading effect with sequential scans from bad query plans. So it was causing the increase in the number of rows that we tried to return there. So it kind of confirmed that it is a good idea to switch off non-critical features. And on top, it's a good idea to conduct emergency drills. So that's something that we want to consider to actually simulate the case of problems by, maybe someone being the chaos monkey and trying to destroy the system and then see how the team reacts. So question number 5 is, why was openqa SUSE QE so severely affected and could not recover itself, but other instances were not? Well, I would say other instances have less data in relevant table, and explain analysis showed the same bad query plans on O3, but they were not impacting the system so much that you could feel it. There are less bot requests on other systems, so we could think of preparing a block list, pass list for requests by user or based on the user agent so that we can provide a quality of service or rate limiting for requests to deliberately slow down requests, especially when the system is too loaded, so to ensure basic services like rate limits for certain slow endpoints. And we are thinking that maybe there are reverse proxy modules like for Apache and Nginx AHA proxy, which could help us there. We were also thinking that we could actually label the SQL queries to be able to identify them, like have a comment within the SQL query so that from PostgreSQL we can identify where a query comes from. Like, was it triggered by a user looking at test overview? Was it triggered by the openqa scheduler, some external script, some API requests? And yeah, we would need more performance. No, this is a note that other systems like O3 has more performance headroom. We would need to get more hardware for OSD, or well, more power for OSD. We are a bit limited there. We are running openqa SUSE on a VM with very good success, and we really would like to keep that, but maybe we can move components like the database itself to a separate VM. Yeah, and we already have an existing ticket, so you can see from the ID, it's actually a bit older. So we already had that idea in the past because we did see the problems, the limitations that we have with openqa SUSE. And it's not as simple as just buy a new server or anything like that, because we need redundancy, we need high availability of openqa SUSE, and the structure right now is providing that. So we need to think of a sensible solution there. So, questions or additions to the 5 whys? Yanis?
Go on. I can.
Yeah, I just wanted to say that I am in the same stage where I was before asking my question.
Okay.
I still haven't heard what was actual problem with the Postgres and how actually it was fixed.
So actually, the problem was that we are using, after the migration, because the structure, the schema changed, meaning that the database is using bad query plans. Okay? So there are query plans, and you can, with the right commands, with PG start statements, is nice to look at. Even in the tickets, if maybe I can find an example for you where we have pasted the output of that query plan, and it's kind of readable. It's like It's like a debugger, or like look at the assembly code that is generated, and then you see what actual low-level code is generated and how long each step takes.
But in I don't know, I don't know much about Postgres query plans, but I have some experience with Oracle query plans.
Yeah.
And in my understanding, again, I'm not like a big database expert, but in my understanding, it's not something which can give you like 10 times boost or 10 times slower. It's just like, it's first of all, it's in basically the back end of database. It's not something which you normally touch by your hand. And also it's something which can just tweak performance a bit, not that something can like really make the database which was running before like 10 seconds to run at 100 seconds or 1 second.
Yeah, right. I mean, I don't want to talk about times that much, because you know, the time very much depends on external system parameters. There was one more thing which we did as mitigation, which already helped a lot. When I was showing you this, not the response, but the rows, what we did from here to here is that we did not yet force a vacuum analyze of all the tables. What we did is we increased the memory per PostgreSQL worker from the default to 64 megabyte. Maybe the default is 4 megabyte. I'm not sure. Is this found? No, you aren't.
So you are saying
that
that
the biggest impact, that we gave each PostgreSQL worker more memory assigned, which it may use, because we identified that we are limited in CPU and memory usage was high, but we were not limited in memory usage. The limit was pure CPU power. And why was that? Because PostgreSQL was using bad queries. And yes, they are not like 1,000 times worse. They are, let's say, maybe 10 times worse, something like that. But 10 times worse, meaning that we would exceed the memory. So Postgres needed to somehow fragment and split the queries, because it couldn't conduct the individual parts of the query within the assigned memory. So it would, you know, kind of swap out to persistent storage and such. And then you could see that significant decrease of performance. So we could mitigate that by giving more memory to each worker. Yeah. And that had the, well, it didn't have the biggest impact, but it had enough impact so that it wasn't feelable as such by you guys as the users. It was still running inefficient queries with much higher memory consumption, but we gave PostgreSQL more memory, so it could handle these inefficient queries.
Okay, so you're saying because of migration from int to big int, database start to require more memory to process the queries?
No, I'm saying because of a change in the schema types. This is when the query planner needs to reevaluate what's good cause. And for a time being, it would run very inefficient queries. As I said, so it's something like a factor of 10 times worse, right? Not 1,000 times worse, 10 times worse. But 10 times worse is enough to exceed the assigned memory. And this is then making it much more worse. Phoenix?
Very mean question, but wouldn't have a reboot resolve that issue?
Why do you think a reboot would resolve the issue?
Because the whole database is restarted, so the query planner should also start from a blank sheet, and therefore the issue should not arise.
That would actually be bad if the query planner loses all its knowledge. So no, a reboot was conducted. I can show you here that this was when an automatic reboot was conducted, and it didn't really help to change the situation. Actually, in the rows, yeah. Okay, sorry, you cannot see there. Let's see if I can find if there's still enough data there. So rows 18th to 19th. Yep. So this you see this ditch. This is the reboot. Okay.
Interesting. Yeah.
So can I take it from here?
Yeah.
Because I had the same question with the reboot, but the system D shouldn't include the PG reset. This is one question, but
Yes. Correct.
and okay, I'm gonna give you my feedback because my trouble is this. Pretty much what you describe is that you knew you obviously you took as much precautions you could, but in practice you deploy on production something that you didn't know, that you knew that it's gonna cause some issues and you didn't even know what this will be. So this is what struck me, that this will then didn't test it, wasn't tested somewhere for a week before go to production.
Yes. So what we tested with is we tested with a database dump of openqa SUSE QE. We tested the migration, and actually, when Marius was timing how long the migration took, for him it took like more than 1 hour to do the migration. And when we conducted the migration on OSD, it only took 18 minutes, the actual migration.
Yeah, but
okay, so it was
after
faster.
migration,
After migration, yes. So what we didn't do is test with the database plus the test results being terabytes of data plus the multitude of requests that would arrive on the system with the exact system performance parameters like the amount of memory, the amount of CPU cores, and the performance of CPU cores. We did not test that anywhere else in before. So why not test that in before, you might ask? Well, because it would be very
no,
very
I'm not asking
expensive.
why. I'm asking if we can improve on this, because you cannot. That sounds like it could go out of hand. Yeah.
Yes. So a good load test or a good performance test would run the system with trying to exceed the actual requirements that could be met, and then any production instance would actually have less load than the testing system. Okay, so we also, and that again was also an idea which we already had in the past. So it's I'm not sure which ticket exactly is that, but we already have that idea noted down. Like, can we, as part of our test, not just unit tests, not just scalability tests where we run thousands of jobs, but really a stress test, can we have a proper stress test included, which would really stress the system as a productive instance would be stressed? We thought about it. I think it's feasible to do. I don't think it's worth the effort to do that right now, and it would be a lot of effort to come to that. Okay. Anything more? So yeah, let's wrap up. So we did mitigate within what I would say a reasonable time. It was a good idea to conduct the migration and deployment at a time which we selected. We do have a good testing framework in place, and we are having a proper disciplined process around even the continuous releasing and continuous deployment. So actually, on openqa OpenSUSE.org, I didn't trigger the deployment because that's also done automatically. We just merged the pull request and waited for an hour, and then it happened automatically. We do have monitoring which tells us about the problem, and now we have learned much more about the nitty-gritty details of database performance and the impact. And yes, we got confirmation for the problems that we already identified in before, which is the performance bottlenecks and such, which can have such detrimental effects. And it just means that we need to put that into the plan accordingly. And I know that many of you as users wouldn't care about scalability or moving Postgres database to another system, because during normal operations you would never see the need for that, and only during such instances then maybe we can make that connections that we need that, and we need to work on that instead of working on awesome cool features or even bug fixes within your workflows, right? Okay, so I'm done. Any further questions or things you learned from that would like to ask or note? Oh, okay, we are good. Then, yeah, databases are hard. Thank you. Yeah, we learned, but it was I would say the complete incident was it was not relaxing. It was a bit stressful. Of course, we want to provide a good service, but I think within the SUSE QE Tools team, we also felt comfortable working on that problem, and we could support each other. So overall, I liked how we handled that very much. Okay, with that, closing that topic. But next week, I need your help. So I'm planning a lightning talk session, in particular about the topic how we review openqa test results by SUSE QE teams. So who volunteers at best from each team to present? Just show us how you review openqa test results. Show some screenshots of weird job failures, share your screen and walk us through how you review test results. Tell us about things that work, tell us about things that don't work, remind us about the external tools or scripts that you use, remind us about the workflow descriptions and such. So really looking forward to your contributions there. There is an Etherpads document. There are already multiple and lightning talks that we had the last time when we had the lightning talk session in February. For oops, sorry, this is actually, I need to update that right now. Should be like this and not bold. So next week, Friday, there's only the intro, and Giku tests is not really giving a talk because this is just an example how you can add your topic. Please add your topic there. Be open. Lightning talk doesn't need any preparation. Just share your screen and boost us away with your result. Okay? Thank you. Until next time. See ya and goodbye.